All right, so we're going to continue on with part B of the part 2 of the grade 6 material. In fact, I might even push it to a part C, so let's see how this goes. All right. In the meantime, what I did was I went back to a previous exam because I want to say something further. We had gotten this here. At one point, we had gotten this expression here, and I rewrote it right here a little neater. What's important to note is that something times 6.4 plus something else times 6.4. This is actually the distributor property, and if you wanted, you could have solved it by doing this right here. Okay. I had explained already that to me personally, getting half of 4.3 and then doing the other stuff wasn't worth it. But you could have certainly done that and gotten 2.15 plus 8.6, right? So that's 5, 7, that's 10.75. And multiplying that by 6.4. Okay, and you should have still got back to 68.8 there. Okay, so I'll leave that as an exercise for you guys to do. In the meantime, we're going to move along for the next question. All right, so there's a visual here again. The volume, wait, where am I? We have some doohickey thing here that's a 4 by 1.3. We can figure out that we probably have to take the area of that bottom piece there somehow. I'm not sure. It seems to be stacked, so probably we're being asked for the height in some manner or being given it. So what they're probably going to do, just out of speculation, this is probably a volume question. Let's see. They're really not giving us anything else there, okay? So a farm of stacked hay bales. So this is A on top of each other in nice compact little bales. The length and width. So traditionally the length is the longer one, and traditionally the width is the shorter one. Okay. So the length and width of each hay bale are shown below. Okay. The volume of each bale is 10 2/3. All right. So I was right. Okay. The farmer stacked 8 hay bales on top of each other. So this whole thing here is one hay bale. So he put 8 going up and up and up. Okay. What is the height in feet of the stacked one? Right. So we have to figure out the height of one of them and then multiply it by 8 basically. Okay. And then in the middle of this, there's mixed fractions and all this other kind of stuff like that. Okay. So the volume is equal to the length times the width times the height. Okay, so you should know that. This is basically the form of a rectangular prism. So that's pretty much what we need to go by. You know, you're not going to get worried that this is zigzagged here. We're just assuming it's formal, it's regular, and the shape as if it was a perfect box, if you will. All right, we're not going to get into that is jagged over here and stuff like that. Okay, so they're telling us the volume is 10 2/3. We know the length is 4. We know the width is 1 1/3. We do not know the height. So it seems to me we need to figure out the height. When we finally get the height, we're going to multiply it by 8. Okay? And then you get the total of all the 8 bales stacked on top of each other. Okay? A lot of kids got this one wrong. There's a couple ways to do this. We can do the 4 times 1/3. So let's convert everything into fractions. So 10 times 10 2/3. Let me reset. 10 2/3 is 32 thirds, right? 10 times 3 is 30 plus the 2 is that. Okay, 4 is 4. 1 1/3 is 4 thirds. Okay, times h. Okay. And that is equal to 16 thirds. Right? 4 times 4 is 16. 4 is the same as itself over 1. So we get 4 over 1 times 4 over 3. We get 16 thirds times h. Okay? We divide both sides by 16 thirds, or it's reciprocal. So that cancels out. what we do to one side, we do to the other. So this was 32 thirds, also times 3/16. The 3's cancel out. The 16 goes into there twice. So we get H is equal to 2. 2 what? Okay, we didn't double check before. This was in feet. That's in feet. So this must also be in feet, 2 feet. So if we have 2 times 8, the total length of the 8 balls is going to be 16 feet. Okay, nothing is asking us to convert it. Let's make sure if we go down here, yep, it says feet. We didn't need to convert it to yards or anything like that. And you can go back and double check your work because it's mixed fractions. They're always tricky and so on. So just make sure your volume is length times width times height. The volume was 10 2/3. So we have 4 times 1 1/3 times H. 10 2/3 is 32 thirds, yes. 4, 1 1/3 is 4 thirds, cool. 16 thirds. We flip that and it all works out and we lived happily ever after. Oh yeah, oh yeah, oh yeah, oh yeah. So this is geometry. It's volume of a rectangular prism. It's also involving mixed fractions and just plain old fractions. Fraction multiplication, mixed fractions, and division by a fraction, which is also the same as multiplication by its reciprocal. All right, so a lot of kids got this wrong, but it's fairly straightforward when it makes sense. I'm guessing enough kids could finally get to the 2, and they got so caught up in all the math they forgot to multiply it by the 8. Always go back and do your thing, or do something like put a Q here so that you'll always know that you're always going to go look that up and see what is the height and feet of the stacked hay bales with the plural, not just one of them. That was a BALES. Okay, all right, so that's that. Oh, this one I think wreaked havoc on the students. So we have what looks like a square and what looks like an expression. And unfortunately, that's all they're telling us. So let's go to the words. A square with one side represented by the expression is shown below. So they're telling you this here, that's the length of a side. That's the length of a side of that rectangle. Okay? Using the properties of operations, whoa, to write three different equivalent expressions to represent the lengths of the other 3 sides of the square. Oi. One of your expressions should contain 2 terms. All right, so what you need to do is, this is one form of the expression. It's asking you to write 3 different forms. Okay? Use the properties, write 3 different equivalent expressions. And one of them should only have 2 terms. Okay? This has this term, that's 1, that's 2, that's 3. So we need one that only has 2. All right? So one way to do this is just apply the distributive property to this. So we're going to get 18x plus 48 plus 32 plus 12x. That's it. That's all they were asking you to do. Okay? So all I did is apply the distributive property. That's one of my things. The next thing I'm going to do to get another form, let's do this in red. I'm going to combine my constants. So I'm going to get 18x. That's 70, that's 80. Plus 12x. That's it. That's all they're asking me to do. And then the third form we're going to do is combine the x's. So I have an 18x and a 12x, that's 10, 20, that's 30x, plus 80. That's all they're asking to do. But there was one gotcha. It says, this last thing says, one of them should contain 2 terms. Well, this contained 1, 2, 3, 4 terms. This contained 1, 2, 3 terms. And this contains 2 terms. Booyah! We got it, bro. We got this. Okay. There's probably other variations of this. You could have we could have done from step number 1. I could have combined the x's first, so I would have gotten 30x plus 48 plus 32. Theoretically, we could do anything. I could have even made this 24 plus 24. That would really be going beyond the scope of what the intention of the question was about, but theoretically is a valid equivalent expression. Okay, so who are they to say, right? You know, we could have taken even number 1 and just added terms. We could have broken each into different parts. Let's say I do 1b here. So I could have had 9x plus 9x plus 40 plus 8 plus 16 plus 16 plus 1x plus 11x. It doesn't matter as long as it's equivalent. That's all they're asking you to do. So do 2 of them that was a variable like that, and the other not. Okay. So it turns out this really wasn't about a square. It looks like a geometry question. It's not. This is about combining like terms. It's about applying the distributive property. That's it. So this is really an algebra question straight up. All right. And a lot of students got this wrong. So be super duper, super duper, duper super correct. And not only on top of all these different forms I wrote out here, they must be equivalent, right? If I made a mistake and made this an 8 right here, okay, then it's not equivalent to the original side up here. All right, so they have to be equivalent. They must be equivalent. All right, that was 58. Okay, 59. Let's see. I like to look at the illustration first. You guys get that hint? I say that every time. This way you get some understanding of what's going on, and when you get to the words, you're reinforcing some of your previous understandings from looking at the illustration. When it goes the opposite way, students tend to either not look at the illustration at all or get lost in the words originally. So what we have is bookcases, okay, and their widths. So A is that, C is that. Oh, this is interesting. The width of D is W and the width of E is W. Say what? Right? So we don't know where they're going, but remember, note units, centimeters. And by the way, guys, if I can do this, every time we come to a problem, I'm saying the same statements. It's just part of your process. And that way, if you practice and get in that habit, positive good habits, then these things don't become idiosyncrasies or fall off somewhere. So it's important to know units every single time you see one. No matter when you see a unit, just say to yourself, are the units all the same? All right? And you're going to have to double check this because we're only still looking at the illustration. You have to make sure the words are good. All right, so a carpenter built 3 bookcases, A, B, and C. Awesome. To stand next to each other along a wall. So we have a wall with A, B is right next to it, and C is right next to it. Okay, so I am not drawing these to scale. Okay, and the total length of the wall is 456 centimeters. Okay, the carpenter, so we're up to here right now, the carpenter will build 2 more bookcases, D and E. Again, this is not to scale, so I'm not saying they're necessarily larger than the others. The 2 bookcases will have equal widths. Okay, so that's where the W's come from here before. And the width of bookcases A, B, and C are shown below. So write and solve an equation. So you cannot just give the answer. You must write and solve, and you must write an equation for starters. An equation must have an equal sign to determine W, the greatest width for the bookcases D and E. Okay, so your equation does not need to say W equals. You can do that if you'd like. So let's try to do everything we have. We have the total length, 456, is equal to the length of A plus the length of B plus the length of C plus the length of D plus the length of E. Okay? So if we plug those in, we get 456 is equal to 132 plus 94 plus 108 plus W plus W. Okay? Now, it says to determine W, so our expression needs to involve W. So this is one expression we could have used. We could have also added up 132, 94, and 108, which is what we're going to have to do anyway. So we get 4, 1, 3, 1. So that, I believe, is 330 floor. I'm going to add those up in a different way just to check that. And I said 330 floor. I don't know why I misspoke that word. Uh, 10, 4, 1, 10, 3, 1. So that's 334. Okay. So we could have written 356 equals 334 plus 2W. That's also a valid expression. Whereas we could have come along, added these up here, and then fed it back in, and this could be our valid. So we're involving W here, we're involving W here. All right? Okay, so solve the equation. We have to solve it now too. So that's partially our solution over here. We have to take the 456. We're going to subtract 334 from both sides. Six minus 4 is 2. 5 minus 3 is 2. So we get 122 is equal to 2W. Divide both sides by 2, and we get W is equal to 61, if I did that right. And I'm just going to add this up here just to make sure I did that right. 334 plus 122 gives 6, 5, 4, 5, 6. Cool, it did. And 61 plus 61 is 122. So W is equal to 61, and that's probably what it says here in centimeters, right? And here's our last clue. First of all, it's a clue that we're in centimeters, and it's our last opportunity to double check. Did we need to do unit conversion? We didn't. We did not need to do any unit conversion. So 61 seems to be about it. And if we want to make sure all that makes sense, right, we could have just, so that's 132. That's 94. That's 108. Okay, and this is 61. And that's 61. If you got an answer like 500, the whole wall is only 456. Or if you got an answer like 2, 2 is probably not enough, because you can even just roughly do this. This is about 150, right? If you estimate it, 150. Okay, this is about 100. And 108 is about 100. Okay, so what do you get there? 350. Okay. This is 450, right? So you have about 100 divided by 2. The answer is about 50. So you could have estimated the answer as well. In fact, I encourage everybody to do that. Remember, an estimate doesn't need to be close. You'll be like, oh my God, you got 50? How do you say that's an estimate? You should have got 60. No. An estimate can be far enough away. Just it has to be magnitudes, though. So if you get 5, that's way too far, right? So you have a delta, you have a room for error when you do estimation. It could be an order, it could be significantly off, especially the number's larger. So being 10% off is not a grandiose mistake in estimation. That's how estimation works. We're just trying to get a ballpark, right? If we weren't trying to get a ballpark, we'd actually do the actual computation. So an estimation would bring us between 50 and 70 if the answer was 60, right? So So that's cool. It worked out. All right. So that's number 59. Okay, I think we have 2 more questions. All right, so Darnell's car used 8 gallons. So Darnell. So there's a few numbers flying around here, and I'm just trying to keep track of what it's saying in English. So we're going to document our journey through this paragraph. Darnell's car used 8 gallons. And again, do we have to do unit conversion? To travel 340 miles. Okay. After a mechanic worked on it, so this is Darnell original, Darnell fixed, should we say, is 7 gallons to go 350 miles. Okay. If the price of gas was approximately $4 per gallon, notice they say approximately. How much less to the nearest cent? So they're talking, when they use terminology like that, they're talking about to the nearest hundredth, right? Because pennies work, cents work in there. So they're not looking for you to get like 0.123 cents. Okay, to the nearest cent they're talking about. Okay, so 1 through 100 basically is what they're per mile. The nearest cent per mile did it cost the car after the mechanic worked on it. All right, so so let's see. It seems to me that if, let me change the color of the pen here. Let's make it red, handy dandy red. That if you want, I would have, you know what? I'm gonna cross this out right here because I want to write along the side of that to document it was the original there. So if it costs $4 per gallon times 8, then it costs approximately $32 to do this. Okay, the same here. If he went for 7 gallons and it cost approximately $4 a gallon, then here he did $28. Okay. I ran out of something to drink here. So those are the 2 total prices he got. So basically what we need to do is figure out 32 over 340. And also 28 over 350. Okay? And that'll give us the price it cost them to go per mile and stuff like that. All right? So 28 over 350 we can do the division, but I can figure out that 4 goes into here 7 times. Wait, sorry, I said that backwards. I try to avoid bigger numbers. So 7 goes into here 4 times. And 7 goes into here 50 times. So 4 over 50 is the same as 8 over 100. So this is 8 cents. Okay, straight up it is. Okay, we could have gone to the side, and we could have done 350 into 28 using the original numbers. Okay. 350 goes into 2? No. 350 goes into 28? No. 350 goes into 280? No. Okay. So we're just stuck with the last thing here. 350 times 10 is 3,500. So 9 is probably be too close because that's 27, 28, right? 9 times 3 is 27, plus that 250 is already too high. So we already know the answer is 8, but we can put 8 here and check it. I would have probably chose 7, but so anyway, let's just double check it. 8 times 5 is 40. Wait, I did that wrong. 8, 0, that's 40, that's 0. The 4 should have been here. 24, 2,800, which is what we have. So we have 8. All right, so we double check that the 8 makes sense. The other one was 32 over 340. Okay, we could start simplifying this, but this probably isn't worth it. Let's give it a shot. We can go divided by 2 is 16. Nothing leaps out at me there. I don't see 3 is divisible. 5 is not divisible. So I'm going to just go with 2. We're going to get 170 here. So we didn't really gain much by using one over the other. But let's do 170 into the 6. 16 rather. Okay, I'm going to put at least 2 zeros because we know it's going to be in dollars and cents. 170 into 1, no. 170 into 16, no. So that's already 0 point. 170 into 160, no. Okay, this one does look closer because 170 times 10 is 1,700. So I'm going to try 9. That's 0, 63, 6, 15. So we get 1530 if I did that right. Okay, that leaves us with what, 70? That would have been a 9 there. We're going to add another 0. So we drop that down. So we get 900, I believe, if I did that right. Let me just make sure. 3, 6, 1530. Yep, it seems to be right. So 170 goes into there. Looks like it might be 4 times. That's going to give us 680. Would 6 work? No, it's 4, I believe. Okay, so that's going to keep us at 9 cents. So this is 9 cents if I did that right. And it's saying how much less. So basically we have 9 cents minus 8 cents equals 1 cent, 0.01, or 1 cent. Okay, so this one is really a word question problem. It involves some mapping ratios and proportions back and forth. Just taking each one at a turn. Rounding, so there's approximation here, right? So we're not getting an exact number here, but we did rounding of it too. So that's really the concept behind this, is doing that. And just trying to set it up properly. The key was what to really need to do with that $4. Where do we put that $4 into here? And do we do something? Do we do 8 divided by the 340? No, I never did that. Okay, because I need to include the dollar amount in it first. I could have done 8 divided by 340 and then multiplied it by 4. That still would have given us the same answer, right? So I could have done 8 divided by 340 times 4. All right, same for this one. I could have done 7 times 350 and then multiplied that by 4 as well. What we want to do is avoid having to do some of these minutia things first, because 350 into 7, that's an ugly division, and then multiplying it by 4. So what we want to do is postpone, do lazy evaluation, it's called. Postpone any calculations until it all makes sense, because we can see if we did this first, we'd have this ugly number and then multiply times 4. We can see here that this is 4 over 1, and it's 28 over that. So it's easier to do that one. And that one was super fast, especially if you use the division thing I showed right here. That was a 2-second calculation. The other one was definitely uglier. Okay? And I think we're finally into the last question. Yay. So 1 cent per mile. Okay. Again, depending on how you're being asked, sometimes they might accept this form, but this is saying it's 100th of a cent. Okay, that's not quite the right way to express it. Okay. Okay. And by the way, the last 2 or 3 questions, maybe all the ones I just did on this session were worth more points than the other session. So these are 3-point questions. The other ones are normally worth 2. The circus had 1 performance at the Dewey Civic Center and 1 at the Atlantic Auditorium. Awesome, the circus is in town. The Dewey Civic Center, so Dewey has 1,600 seats. So we're up to here. Tickets for 85% of the total number of seats. This is the total, right? It says it has that many. So 85% were sold. How many were sold? So sold is equal to the number of seats, the total seats, times 85%. Okay? So the number sold is 1,600 times 85 over 100. Okay? These 2 zeros go away, these 2 zeros go away. So I'm left with 85 times 16. We get 30, 3, 48, 51, 5, 8, 0, 6. We get 1360. Should be the number of seats. Let's do that upside down. 18 times 16 times 85. 0, 3, 8, 48, 4, 12, 0, 6, yep, 1360. So that's 1360 tickets. All right, so this really comes down to mapping the English into the algebra and doing this nasty double-digit multiplication. All right, and being clear how to do it. To me, it wasn't worth doing 1,600 times 85 and then dividing whatever that would have turned out to be 1360, 00. That doesn't seem to have been worth it to me. I like to work with smaller, cleaner numbers whenever possible. All right. And I'm getting a phone call in the middle of this. I wrote 136. That's 1360. Okay, you could be clever and say how many tickets were sold? 85% of them. Okay, technically that's a correct answer. It says tickets were sold. How many tickets were sold? 85% of them. But it's clear they want you to actually do the computation and figure that out, right? Okay, so you can't be a wise guy and get credit for that. Okay, the next thing, there's a part 2 to this, I believe. Yes, so the Atlantic Auditorium has 850 seats. Let me change the color for that so that we can use the space here without me scrolling off the page. So the Atlantic has 850 seats. Tickets were sold for 816 of the seats. So sold was 816. Find the percent that was sold. So it's the sold out of the total. Okay, so that would give us 816 over 850. Okay, so we can do similar than we did before. We can figure out if can we trivialize, simplify this fraction. No, because this is really only divisible by a 5 or a 10, because it ends in a 0. So there's really no. We can divide by 2 for certain, and get 408 over 425. but there's really nowhere else we can go with this. So neither one of these is better than the other. So basically we have to sweat it out and actually do that division. So we can do 850. Where can I do that? Let me scroll this so we get a little workspace. 850 goes into 816. And just to be clear on the both of these, when we did those divisions, the upside down divisions would have given us the other number. All right. The previous problem I'm talking about here, I think. When I did like the 350 into the 280, if we did that, the 28 into 350, or the 32 into the 340, those would have been upside down answers. Okay. So we're going to do 850 into here. 10, it seems close. So 850 into 8, no. 850 into 81, no. 850 into 816, no. So we're 0. We bring up the dot. We're pretty close to being 10 times because it would be 8,500 versus 8,160. So 9 probably works. 9, 0, 45, 4, 72 plus that is 76. Okay, let me just double check I did that right. 0, 45, 4, 72, 76. Yep, so we're going to get 76. 50. There's the 9 for that. We're going to do the subtraction. So we're going to get 0, 1, 5, 5, 10, I believe there. All right. We're going to drop down to 0. We'll just make sure I did that subtraction right. 1, 4, 5. Yeah, I think so. So 850 into 5100. 4 is about 3200. I'm going to go with 5. Let's test 5. 850 times 5. 0. 5 times 5 is 25. 2. 42. Can we throw another 850 in there? We might be able to. 850 times 6. 0, 30, 48, 51. Yep. So we get 98 is the answer. Wait, sorry, no, 96. Okay, we can go on the side and double check that because 850 times 0.96. 0, 6 times 5 is 30, 0, 3, 48, 51, 9 times 0 is 0, 45, 4, 72, 76. We add them up. Got 0, 0, 6, 1, right? 816. We move 2 decimals here. We move 2 decimals there. And we get the 816 back that we originally started from. Alrighty, yeah, booyah. All right, so hopefully you guys are enjoying this. So the answer to here would have been 96%. Again, do not write 0.96. That's less than 1%. The answer is almost 100%. Okay, and we can make sense out of this. Almost all tickets sold, right? If we go up here, right, 816 is close enough to 850 that you should probably figure out, oh, we probably sold 90-something% as an estimate, right? So if you did the division wrong and got like 16%, that would, 10% of this is 85, right? 10% of 850 is 85. So if you got a number like that, you know it has to be wrong, so you're off base. All right? All right, I wish you guys a great day, and I hope you're enjoying this. Please like, please subscribe, please share, please smash the daylights, add the like button, and double peace out, guys.